In this class, I'm going to start new module 4, Statistical Methods. Already you people familiar with the statistics, so just we recall some more definitions of statistics. First one is the classification. Classification is nothing but the process of arrangement in given data in different groups. So the significance of a large mass of statistical data known as raw data cannot be understood unless it is arranged in some definite manner. So the process of arrangement in different groups is called classification. A frequency table, it is a tabular arrangement consisting of various classes of uniform size known as class intervals, and the number in each class is known as frequency. Next, variate. Variate is what? It is a quantity which can have different numerical values. For example, in the statistics, price, marks, height, weight, age, these are all act as variates. Mean, if x1, x2, x3, so on, xn be a set of n values of variate x, then the mean x bar is defined as x bar equal to 1 by n summation over I equal to 1 to n xi, or else you may write it as simply x bar equal to summation x by n. This for grouped data in the form of frequency distribution, we write the mean as with this formula x bar equal to summation over I equal to 1 to n fi xi by summation of I equal to 1 to n fi, or summation of fx divided by summation f. Variance v, if variate x takes values x1, x2, x3 up to xn, then the variate v is defined as v equal to summation of x minus x bar whole square divided by n. All these already you have studied. Next, again for group data, variance is defined using the formula summation of f of x minus x bar whole square divided by summation of f. Standard deviation is square root of your variance, that is sigma equal to square root of v, or else you write sigma square is v. For a group data, this standard deviation expression is, it can be written as summation of f of x square divided by summation of f minus x bar whole square. So this is some basic about our statistical stats, basic about our stat. Next, in this module, mainly you study correlation and regression. Correlation is what? Correlation is a study of relationship between any two given variables. So two variables are said to be correlated if the change in one variable results in a corresponding change in the other variable. In the correlation is it is a statistical tool which studies the relationship between two variables. It always involves an analysis using various methods and techniques to study and measure the extent to which a relationship between the two variables exist. Correlation is concerned with the measurement of strength of association between variables. So the degree of association between two or more variables is termed as correlation. So in just studying all these points about correlation, we can define it as it is an analysis which helps us to decide strength of the variables, linear relationship between given two variables. The word itself decides the degree of association between variables. If two variables x and y are so related, the variables in the magnitude of one variable tend to be accompanied by variations in the magnitude of the other variable, then they are said to be correlated. So we can define overall correlation as the measure of the extent and the direction of the relationship between two variables in a bivariate distribution. For example, height and weight of the children, an increase in the price of commodity by a decrease in the quantity demanded. Such examples gives us a relation between two quantities, between height and weight, between price in the commodity, it depends on the decrease of the quantity which being demanded. So correlations are of three types: positive and negative correlation, simple, partial and multiple correlation, linear and non-linear correlation. In this module, we are concentrating on positive and negative correlation. Correlation first developed by Sir Francis Galton 1822 to 1911 and then reformulated by Carl Pearson 1857 to 1936. Here now the standard method we are going to use is one which is developed by Carl Pearson. We are going to use positive and negative correlation means what? If both the variables are varying in the same direction, that is, if one variable is increasing and the other on an average is also increasing, or if as one variable is decreasing, the other on an average is also decreasing, then correlation is said to be positive. In a simple way, we can say that if x increases, if x and y are two variables, then if x increases, y also increases. If x decreases, y also decreases. Means both the direction of increasing or decreasing is same way. So then we call them as they are correlated positively. So that is a positive correlation. On the other hand, if one variable increases, other decreases, or vice versa, then correlation is said to be negative. For example, heights and weights. If height of a person increases, automatically weight also increases. So height and weight are correlated, positively correlated. Amount of rainfall and yields of crops. If you get a good amount of rainfall, then we'll get a good yield. So this is a positive correlation. Price and supply of a commodity, income and expenditure on luxury goods, blood pressure and age, etc. These are all positively correlated variables. For next example, price and demand of commodity is one increases and the decreases. That is a negative correlation. Sales of woolen garments and the day's temperature. These are all examples for negative correlation. Next comes the method to study correlation. Carl Pearson's coefficient of correlation is the one of the method for studying correlation. It is the numerical measure of correlation between two variables x and y, usually denoted by r, and is defined as follows. R equal to summation over n, 1 equal to n x minus x bar into y minus y bar whole divided by n into sigma x into sigma y. X bar and y bar are means, n is a total number of data terms, sigma x and sigma y are standard deviation with respect to x and y. Same formula can be put in another form by substituting capital X as x minus x bar and y as capital Y as y minus y bar. So we can rewrite sigma x square as summation of x minus x bar by whole square divided by n as summation of capital X square divided by n. Same way, sigma y square can be written as summation of capital Y square by n. So sigma x into sigma y can be written as square root of sigma x capital X square root of summation capital Y square divided by n, or n into sigma x sigma y equal to square root of summation of x square into square root of summation of y square. So substituting these in equation 1, we get r as summation of x into y capital X into y whole divided by square root of summation x square into square root of summation y square. This is the formula for correlation coefficient in terms of capital X and y, which represents the means x minus x bar and y minus y bar. Formula for the correlation coefficient r in terms of standard deviation is another formula which is given by r equal to sigma x square plus sigma y square minus sigma x minus y square divided by 2 times sigma x into sigma y. So note, in general, if z is equal to ax plus by, then we can obtain sigma z square equal to a square into sigma x square plus b square into sigma y square plus 2 times rab sigma x into sigma y. So this is all about correlation coefficient. In the next class we are going to discuss about regression definition, regression equation for the regression lines, and examples on correlation coefficient and regression.